Welcome to this video on graphing cosecant. Cosecant is more commonly known as cosec x, or the graph of y equals cosec x. So the title in the slide is graphing cosec x, and that will be the graph we are looking at. We're going to understand what the cosecant graph looks like and what its domain and its range is. First of all, let's say or define what cosec x is. Cosec x is 1 over sine x. So if we're going to draw the graph of cosec x, it makes sense that we draw sine x first to help us to work out the values of cosec x. Okay, so what I'm going to do now is I'm going to just, for the sake of this example, I'm going to consider what cosec x looks like between 0 and 360 degrees. So I'm going to begin to start drawing the axis of this here. This is the y-axis. I'm just going to label that up there. And across here is the x-axis. Okay, I'm just going to put some lines on here. So that's going to be 1, and that's going to be -1. Put a little bit of scale in here to help me draw the sine x graph to start with. And we know that it's going to be at about 90. That sine x will equal 1 at 90, so it's got to go through that point approximately. It's a sketch, so it's not got to be perfect. And then, of course, sine x is -1 at x equals 270 degrees. So I'm just putting that in there. Right, I'm now going to just try and draw in orange the graph y equals sine x. I'll try and get a nice curve in here. It's not bad. Okay, good. Now I've got to work out what cosec x looks like. And the way to do this is to consider key points of sine x, and then do, in order to work out cosec x, do 1 divided by sine x. So as I've said earlier on today, when x equals 90, sine x is equal to 1. Therefore, cosec x would equal 1. So what we can see is that my cosec graph will go through x equals 90, y equals 1. Likewise, when x is 270, sine x is equal to -1. So cosec x would equal -1. Now comes the question, what happens when the value of sine x is equal to 0? For example, when x is equal to 180 or 360 or 0, sine x is 0. So what would cosec x be? Well, 1 divided by 0, it's undefined. It's essentially infinity. As we approach 0, or as we approach 180, the value tends towards infinity. So we draw this as an asymptote. So I'm going to start to put an asymptote is a line on the graph where there is no solution. So there's an asymptote at x equals 180. There's an asymptote at x equals 360, and there's an asymptote at x equals 0. Okay, now what we can also do, and I'm just going to sort of dash this in here to give us a rough idea of shape, and then I'll go over it once we've got the idea of the shape. What we can see from this point here, from the x equals 90 point, let's consider what our graph will look like from between 90 degrees, x equals 90 to x equals 180. Well, our sine x graph gets smaller, which means our cosec x graph must get bigger. Okay, if you do 1 divided by a number less than 1, the value gets bigger. However, we do know that this graph is going to go up to infinity, like this. And if we think about what's going to happen between x equals 0 and 90, we can see that the graph is going to go up the other way. Okay. Then when we consider the other half of the graph, let's put together from the point x equals 270. We know that y is -1 for sine x. We know that this cosec x is also -1 at 270. And as we go to 360, the value is going to become more negative, and it's going to go towards infinity. And then as we go from 270 back towards 180, again, cosec x is going to become more negative. Okay, this isn't the best sketch in the world, but what I'm going to do now is I'm going to draw this, rather than try and draw it in pen, I'm going to try and draw it in highlight. That's better to get a nicer shape. So this green line I'm drawing is what the graph y equals cosec x would look like. We can see that the domain of the cosec x graph, i.e. what the x values are x belongs to all real values except x does not equal a value of pi. Now, if you remember pi, is 180 degrees, is equivalent to 180 degrees. I'm just going to put pi in there. I'm going to put 2 pi in there. What we can see is that our domain, our series of x values, this graph will have, the cosec graph will take all x values except where x is some integer value of pi. So what is the range of cosec x? Well, the range of cosec x is going to be y is greater than or equal to 1, or y is less than or equal to -1. And that's how we draw cosec x, and that's the domain and the range of that function. Thanks for watching. If you'd like to know more about sketching different graphs of secant or cosecant or cotangent, and find out the maximum and minimum values of these functions, please join us at kippersconsultancy.co.uk, where you can meet other students and tutors, have your harder questions answered, build confidence, and access higher grades. Thank you.